Hello everyone, I'm Adithya. I scored a 99.64 percentile in CAT 2023 and also got a 99.71 percentile in the DILR section. So today we'll try to do a DILR set from the CAT 2022 slot 1 paper. So I'll just share my screen and we can get started. We'll just take a quick look at the question. It says 6 interviewers, A, B, C, D, E, and F, are the interviewers in a process that awards funding for new initiatives. Every interviewer individually interviews each candidate and awards a token only if she recommends funding. A token has a face value of 2, 3, 5, 7, 11, or 13. Okay, so this could be an important point later than this one. Each interviewer awards tokens of a single face value only. Now, the reason this could be important is that you have to understand that none of these interviewers can give tokens of more than one value to the candidate. So if A is giving a token of 2, it will be 2 to each of the participants. It's not going to be 3 to 1, 5 to another, etc. Once all 6 interviews are over per candidate, the candidate receives funding that is 1,000 times the product of the face value of all tokens. Just to clear that up for us, they've also given us an example. If a candidate has tokens with the face value 2, 5, and 7, they get a funding of 2 into 5 into 7 into the 1,000 rupees, so 70,000 rupees. Fantastic. P, Q, R, S, and T were the 5 candidates who received funding. They received funding in descending order: 3,90,000, 2,10,000, 1,65,000, 77, and 66,000. So these are not respective values, but rather they've just arranged 5 values in descending order, and we will probably have to figure out who gets how much money. They've also given us 3 facts saying that F awarded tokens to everyone except Q, A awarded tokens to no one except P, R received the highest number of tokens, but she did not receive one from E, and B awarded a token to S but not to Q, while D has done the opposite, awarded one to Q but not to S. All right, so from a personal note over here, I tried this set during a mock preparation about 1 or 2 months before my CAT exam, and this set appealed to me a lot because I really love sets involving grids and tables. I think I tried it first, ran into a bit of a roadblock, so finished off another set, then the logic occurred to me, so I came back and I was able to crack this set. Whenever I do a set involving grids and tables, I like to arrange my data into a matrix. So I've just made one here, something like this. Here I've put the interviewers' names as the column heads, and the row heads are nothing but the names of all our candidates. The reason I like this, even though it might take you a little longer in time, it gives you a very comprehensive view of your data. It helps you understand how you work to certain conclusions, trace back on your steps, and also it helps you to eliminate options very easily. So some instances where you're not able to find a final answer, you might still be able to arrive at an answer by eliminating 2 or even 3 options if you're lucky. All right, so with that, we can start with the question. So I would like to start by seeing the 3 points that we have over here. Firstly, we know that F has awarded tokens to everyone except Q. So we can just mark that in our table over here. Usually when I do it on pen and paper, I like to use ticks and crosses because it's very easy and saves a little time. Here, I will just do it with Y's to signify yes and N's to signify no. So except Q, F has given one to everyone. And they've told us that A has done the opposite. A has given a token to no one except P. Right? So P is the only one to have received at least a token from A. All right. What else do we have here? Point 2 tells us Rashida received the highest number of tokens, but not one from E. So here I'll just mark the small h beside Rashida's name so that we will later remember that she has to have the highest number of tokens. How many that is, we can come to later. But importantly, she has not received one from E. So I'll just put an N over here. The third point tells us B awarded token to S but not Q, and D has done the opposite. So we'll just mark that as well. B has given one to S and not to Q. Yeah. And D has done the opposite. All right. So just now, this is actually where I got stuck while I was trying the question out. I came to this almost immediately. I took less than 2 minutes to drop this much of the table, and then I did not know what to do because there's only 3 points given. Here, I realized that there's essentially 4 elements in this set. We have 6 interviewers, 5 candidates, but we also have 2 sets of numbers. The first one is the face value of the tokens, 2, 3, 5, 7, 11, or 13. And the second one is the total value that the candidates have received. So a combination of these numbers and 1,000 rupees. So essentially what I try to do over here, I try to find some sort of a relationship between our token values and our sum of the total product over here. So for example, just to pick out a random number, let's say 77,000. Can I express 77,000 as 1,000 into some product of these numbers? And you'll find quite simply, yeah, I can. 7 into 11 into 1,000 gives us 77,000. Similarly, all of these numbers can be expressed as probably 1,000 into some sort of combination of these token values over here. So what we could do is we could put that into a similar table like this and try to solve. So if you look at this table, essentially what I've tried over here, I've put the token values as the column heads, and the row heads is nothing but the sum received by the candidates. The idea behind this was to replicate what I've done here, putting the interviewers who are giving out the tokens as the column heads and the candidates who are receiving the sum as the row heads. This could probably help us a little later, but we'll try to first fill out this table. Coming 390, I've removed the thousands over here to make our calculations easier. 390, from the top of my head, I can say 39 is nothing but 13 into 3 into 10. So 13 into 3 into 2 into 5. So I'll just do a similar system of yeses and nos over here. Fantastic. Now, similarly, 210 is probably 21 into 10, which is 3 into 7 into 5 into 2. All right. 165 will be 15 into 11. So 15 is 3 into 5, so we can do it. Right? 77, we just discussed it earlier as well, 7 into 11. I can mark all the others confidently as no's. Right? And 66 is 6 into 11, so 2 into 3 into 11. All right. So now what we've done is we've given some sort of a meaning or some sort of a relationship between these token values and the sums collected by the participants. Now let's try to link the numbers to the names. We'll start looking for basic patterns in the data and try to see what we can make out of it. So the first thing that came to my mind over here was, if you look at the number 13, the token value of 13, it has occurred only once in these 5 numbers. And the reason I found that interesting is if you look at the question, it tells you that A has awarded tokens to no one except B, which means the value of token that A had, she gave it only once. And we found out that 13 occurs only once. So I can confidently say that A has awarded tokens of the value 13. But for me, I think more importantly than this, the takeaway was that the total sum that P has to have received as a result is 3,90,000. Now, I'll just mark it as 390 here. Now, the reason you can see quite clearly, A has given tokens of value 13, but she's given it to only one person. And the one person who had received a value of a token with the value of 13 has received a total sum of 390. So with that reasoning, I've been able to say 2 things: A's token value as well as the total sum of money P has received. Now we'll come across something little more in depth over here. If you look at the value 390, it has been expressed as a product of 4 different numbers: 2, 3, 5, and 13. And the reason I'm bringing that up over here is because we can do this similar calculation for all of our values. I think 165 will be of 3 different numbers. All right. This could be important because we marked an H next to Rashida's name because the question tells us that R has received the highest number of tokens anyone received. And we have seen that only 2 numbers they're tied for the highest with 4 tokens each. 390 is 2 into 3 into 5 into 13. 210 is 2 into 3 into 5 into 7. So, but we already know that P has received a total sum of 390. So I will come to a logical conclusion that the total value that R has received has to be 210 to ensure that R has received a maximum possible number of tokens, right? So I will put 210 for R. Continuing along the same line, we know that R has to have received a token, at least 4 tokens out from the 6 interviewers. Here we will see that R has already been rejected by A and by E, and she has only been accepted by Y for now. So I will just go ahead and say that R has to have received funding from both B, C, and D to ensure that she has 4 unique interviewers who have given her money. Done. Now, we used a certain logic to arrive at the fact that A has given out tokens worth 13 and the value for P. So we can use the same logic again over here. If you look at this point, it says F has awarded tokens to everyone except Q. Why would that be important when you look at the numbers over here? Look at the number 3, for example. Every single number over here can be expressed as a product of other numbers, including 3, except for 77. 77 is just 7 into 11. What does that mean over here? Two things. Firstly, F has to be handing out tokens of the value 3 because it occurs 4 times. It does not occur only once. And more importantly, who did F leave out? She left out Q. And Q has to be 77 in value. All right. Now that gives us fair this depth into our question, because now we have found out that 2 interviewers have given out values of 13 and 3, and we found out unique values for 3 of the 5 candidates. Here, what we can do is we can continue to look at these numbers and look for any sort of trends and patterns. And when one thing I found out immediately almost was when you look at R's funding. R has received funding from B, C, D, and F. We know that the value of F has to be 3. We do not know the values of B, C, and D also, but the thing that could be a hint for us is that she has been rejected by both A and E. And we know for a fact that the value of A is 13. So let's come to 210 here. You have 2 no's that are received. R does not have a value of 13 in her funding, and she also does not have a value of 11. We already know that A is handing out tokens worth 13 and A has said no to R. Similarly, we know E has said no to R. So my logical conclusion here would be that E has to be giving out tokens worth 11. What does this tell us further? Let's come to Q, for example. We know Q's total value has been 77, and 77 we expressed it earlier as 7 into 11. So we have to, and we know that D has given some sort of funding. So we would have said has to be 7 or 11, but D cannot be 11 because we already know E is handing out tokens worth 11. So I'll just tell you that D is going to be handing out tokens worth 7. All right. So based on this, we can try to fill out other numbers. We know 390 does not have a 7 in it, so we can mark this as a no. We do not know this, so we leave it blank. We know 390 does not have 11, mark it as no. We know that 77 does have 11 in it, we'll mark it as yes. We can leave these two blank. And of course, this whatever it is, it has to be a blank because 77 has been fulfilled. Now let's look at the 2 numbers that we have pending and see what we can make out of it. 66 and 165. I'll just highlight these numbers. All right. So we know that 66 can be expressed as 2 into 3 into 11, while 165 can be expressed as 3 into 5 into 11. So if you notice over here, the numbers 3 and the number 11 comes as common for both of them. The only difference is whether you have a 2 or a 5. And that's a problem we are stuck with over here. We don't know if B is a 2 or a 5. And we also don't know the same for C. All right. But we do know that since both 66 and 165 have 11, both of them have to have received funding from E. So I'll mark these two also as Y's. All right. Sorry. Done. Now, one thing we could do over here is we could probably take out 2 cases and we could try to find out what might fit or what might not fit over here. Before that, I'll just tell you one last point. We know that P received funding from 4 different people. One was 13, one was 3, and the other 2 were 2 and 5. So irrespective of whether B is handing out tokens of 2 or 5, we know that P has to have received funding from both of them. Done. Now, over here, what we can do is we could probably take out two cases. Number one, where we assume that S is actually 66, and number two, where S is 165, just to see how it works out. Or another thing we can do, we can just fill out test values over here and see how it works out. Now, maybe my first case, let me assume that S is 66, and we'll see how it works out. 66, as we have discussed earlier, is nothing but 2 into 3 into 11. And since S has received funding from B, and we will safely assume that B is handing out tokens worth 2, and S does not receive funding over here. I'm sorry. Yeah, S does not receive funding over here. And we can also, as a result of that, try to complete this row. If S is handing out tokens worth 66, so S has received funding worth 66, she has to have received 2, 3, and 11. And naturally, T would have received tokens worth 5, 3, and 11. 3 and 11 are accounted for. B is handing out tokens worth of 2, and C is handing out tokens worth of 5. I'll just clean this up a bit. Yes. So this is a assumption we can make, guessing that if B is handing out tokens worth 2, C is handing out tokens worth 5, does the set fill itself, or is there some inconsistency? And we notice there's no inconsistency. But we cannot just sit on this answer and go ahead, because there's another possibility. The fact that S could be worth getting money worth 165 and T gets 66. So we'll just try out that possibility also. All right, over here, we will have to exchange these two then. And the reason we'll have to exchange it, we know for a fact that S has received a token from T. And if it's 165, the only differentiator between S and T will be the number 2 or 5. And since S over here has received 165, the differentiator has to be 5. All right, and the rest of the set remains the same. So we see that S is nothing but 5 into 3 into 11, 165. 2 into 3 into 11 gives T a funding of 66. And this also maintains consistency. So we cannot come to a conclusive answer over here saying that S has received a particular number and B is giving out a specific number of tokens either. So what we can do in such cases is we can leave it blank, hoping that maybe the questions give us some sort of additional information, or maybe this is all that is possible from this set. We have fairly covered all the points. We'll just review that once, and we can also make sure we've not missed out on any information. All right. 566. So we'll just leave it like this for now. And this is it. So this much we have not been able to find out, but that is basically these two boxes and these two final values. Let's just quickly review what we have done here. We were told that there are 6 interviewers handing out specific number of tokens. And based on three points, we made some headway into the set, saying that F has awarded tokens to these many people, A has not awarded, and filled up some blanks. Then we try to get some sort of a relationship between the token values and the values collected by our candidates. For this, we made a comprehensive table where we were able to express all of these numbers as products of some prime number token values. And based on this, we try to match the two tables, what corresponds to these values in the table and what corresponds to the names over here. And we were able to not completely find, we were able to find out 3 of the 5 candidates, how much money they've taken away. And also 4 of the 6 interviewers, how much money were they giving away. So based on this, we could try to get into the questions. Now, essentially coming here, we have 5 questions in the set. 3 questions are all theta and 2 questions are MCQs. So, and there's no sort of additional information given. So we could be fairly sure that we have not missed out on any information or we've not made any mistake. Let's try to solve them now. How many tokens did Q receive? So we'll just get into our working space over here. And we see that Q has received tokens from only 2 people, right? D and D. So we can safely answer that the answer here has to be 2. who among the following definitely received a token from B, but not from D? What does our working space tell us? B, but not from D, which means we need a yes over here and a no over here. Straight up, we see P satisfies the condition. Yes over here and a no over here. Q gives us the exact opposite, and R tells us there's a yes from both. And like we just tested out two cases, this could go either way. But they've asked us for a definite answer, so I will safely mark P as my correct option, and I will move on to the next question. Earlier in the set, I was talking about why I like to represent my data in such an arrangement, and it is for reasons like this. Here, in just a single glance, I'm able to take away a lot of information and also eliminate options as quickly as I'm able to select the right answer. All right. Question number 3, how many tokens did Chaya receive? How many tokens Chaya give, I think? Chaya award, yes. How many tokens did C award? All right. So C is giving out tokens worth either 5 or 2. We cannot say for sure, right? And we know for sure that C has already awarded tokens to P and to R. When we tested out two cases here, we saw that if S has received tokens worth of 66, then we can say that C has not given a token to S, C has to give a token only to T. Vice versa, if S has received a total value of 165, then C will be the one who's giving a value over here, giving the token over here. So whatever the case is, the answer here has to come to 3. We don't know who are the 3 people, but we know for sure 3 people have been awarded. If you want to test it another way, you can come to this table. Either 2 or 5, you could take a look, because we know C is giving out tokens of either value 2 or value 5. 2 has been awarded to 3 different candidates. 5 has also been awarded to 3 different candidates. So the value that C is giving has to be, sorry, 3 different candidates. The value that C has handed out has to be 3. There's no question about that. We can safely mark this and move ahead. How many tokens did S receive? Similarly, we know S has to be 65 or 166. So I won't even bother with that table. I'll come here and look at 165. We have 3, 5, and 11. If it's 66, we have 2, 3, and 11. And the answer is going to be 3 once again. Right? Which of the following could be the amount of funding that T has received? Now, we left this inconclusively. We were not able to find a solid value, but we found out it could be either of 66 or 165. And the question tells us that it is either 66 or 165. So neither A or B, only A, only B. We did not come to a conclusive answer. So we will mark option C as the answer and say that it can be both A and B, right? And with that, we have completed the set. We have been able to solve all the 5 questions correctly. So just some closing notes on this. My first opinion on this set was that it's definitely a doable set. You know, there's not too much complication in the questions. The questions are fairly direct as well. The only place where I got stuck was putting some sort of a sense between what the numbers are telling us and what the names are telling us. Once I was able to make a breakthrough and draw the second table to give the relationship between the token value and the amount collected, the set went very smoothly after that, and I was able to solve the whole set within a total of, I think, 8 minutes for the whole set. So in my opinion, this is a set that's definitely doable, and given how the overall DILR was in that particular year, I think this was a set you could have done for sure and also answered all 5 questions. Thank you very much.